Good afternoon, everyone. My name is Ganesh Shenbagaraman from Radisys. So I head the function of standardization and ecosystem partnership along with government regulatory affairs. But today's presentation, I'm representing the OSC, ORAN OSC views as a TOC member. And I see many of our colleagues here from the OSC community. So this session is going to be about the open source CU and DU. We'll talk about our journey of collaboration, integration, and the struggles we have had, challenges we have had, and so on. So to set the context, we'll talk about the role of reference design, and probably this was already covered briefly in the session by David, but I would like to give my view of it. And again, we'll talk about the implementation details and the ongoing collaboration, plus all the challenges and the road ahead, right? So this is the view of how ORAN is organized as various working groups, focus groups. If you look at it, there is a whole lot of detail that ORAN gets into, right? Not just from the theoretical aspects in terms of the actual use cases, architectural aspects, implementation details, how do you manage the network, and so on. So it's use cases, interfaces, architecture, all the infrastructure elements, security, and a whole lot of focus on the management orchestration and the service models, and of course, testing and integration. And as a result, ORAN produces a volume of output and almost 3 releases in a year. And we get white papers, technical reports, which are more like study reports, a lot of implementation-oriented specifications. We also have reference design specifications, data models, and test specifications, right? So we have 2 major reference design working groups within ORAN. One is focused on the hardware design, which is mostly to do with the radio hardware, the base station hardware, and the focus is to see how much we can decouple and make this hardware white box as much as possible. Right? Multiple reference designs are available from Working Group 7's focus and output. And you could see the detailed design specifications of various components and circuitry in the hardware side. When it comes to the stack reference design or the software aspects, Working Group 8, which I represent as a co-chair, we have a lot of focus on actually implementing the base station, the reference architecture. This is not a mandatory specification, it's more a informational one, and that way it is not binding or mandatory on anyone. It's not a normative spec, but we have a whole lot of details covered, especially the building blocks of the various functions within DU and CU, and the various different APIs or function calls between the modules that constitutes the DU and CU. And these also relate to the external interfaces and the O&M interface. So if I have to represent this in a different way in terms of how this is all distilled into different specification stages, from an ORAN point of view, we have this release concept now. There is an MVP release, which is the minimum viable package, as it is called. There are a set of features which are picked up for each set of releases in ORAN, and right from the use cases to the architecture, there's a detailed work that is done on the feature specification at a study level, and then an architecture level interface and the implementation spec. And that is further translated into call flows, data models, and profiles. So this forms the reference for our working group Working Group 8 to design what we call as the architecture and API design document. And what we do here is a component level description, and we come up with a reference design, and of course we can, this is software and you can implement in many different ways, and then you can come up with alternative implementation. But what we have done through the contribution that is happening within the working group, we arrive at the common approach or the desired approach of reference design. And we also produce what is called the IoT test specification, which tests the DU, CU, RU interop. The IoT here is mostly limited to the interrupts among the three elements of DU, CU, and RU. And we have 70 odd test cases, 70 plus test cases now. And this forms the basis for implementing the same in an open reference implementation within the open source community, the ORAN OSC, for the OCU and ODU. Of course, the ORU tends to be a lot more hardware oriented. There is no real reference design spec from a software point of view there. So this all is picked up in the OSC community and the labs and TFG and OTIC and whatnot. In terms of our focus, we have a lot of these building block level descriptions based on the 3GPP releases primarily and the output of various working groups within ORAN, including the cloud working group, which is WG6, and the security aspects. So all aspects of implementation are being referenced in this spec. And we have focused a whole lot in the initial few releases, especially the aspect of MAC scheduler API. There is an inherent element of scheduler logic that differentiates the ODU. And the desire is to have the pluggability of different scheduler algorithms and modules. And we have designed, one of the key achievements in this specification is to have that level of separation and clearly defined, well-defined APIs between MAC and scheduler, so that a particular implementation of scheduler can replace the current implementation, and you can play with the flavors of scheduler logic and see how the impact of various scheduler algorithms can impact the performance. And we have around 40 APIs defined between MAC and scheduler, both for the uplink and downlink transmission between the MAC and scheduler and the underlying physical layer. And we are also using the open interface of FAPI between MAC and PHY layer. And of course, there's a whole lot of call flows and features. About the test specifications, and as I already said, there is a focus on OCU, ODU, and ORU interop, and we have written a bunch of test cases. Now some of these are being picked up for the plugfest, and we have defined test profiles for different use cases, and then these are now being referenced. And again, TFG, the group which looks at all the test specification, they also review our test cases, and there is an internal badging process that happens within ORAN Alliance. So this test specification from ORAN Working Group 8 is also going through that process. And we have a bunch of features, which are MVP features, which are referenced and elaborated further in the test cases. So what we see here is a virtuous cycle of implementation flowing from the specification. Then when it comes to design or code or testing, we can improve the specification. We can find issues either in design or a code level or implementation level issue, or when we test, all of this goes back as feedback to the specification. And this is the virtuous cycle anyway through the open source community, having the reference design and having a blueprint and the correction opportunities there at every step. And as David highlighted in his talk earlier, there are in some cases, we go ahead of the specification and implement something that can finally become an approved specification as well through the feedback process. So today, as we stand within the ORAN open source community, we have the OCU, which is mostly available in the binary form, and right now we are in collaboration with the OAA team to use their OCU. And there is a software team which is working on the ODU software development, what we call as the ODU High, which is focused on all the layer 2 MAC RLC scheduler related aspects, along with the other O1 E2 interface related logic. So that team is a team which has been in play for last 5 years, starting around middle of 2019. The announcement of the open source community happened right here in San Jose in 2019 April. So it's full 5 years since we started our journey. And this team, the ODU High team, has been around for 5 years. So we have improved this code over a period of time. And currently we have a set of features which I will quickly cover. And the ODU Low can be any ORAN compliant ODU Low implementation. Currently we are in an integration effort. So right now we have in the open source community, ORAN open source community, the Fluxran 5 based ODU binary, and the project lead is from Intel. And the ODU High project lead is, of course, Radisys. So in terms of an architectural view, this is a very simplified view of how this ODU high code is organized. We have all the elements of that, what makes a complete G node be. We have a set of features including FDD, TDD, and then a lot of functionality. And we are trying to use as much as common code, for example, the ASN decoders or the same ASN encode decode libraries which are used in the RIC. So there's a lot of reuse and commonality in this, the way it is structured and modularized. In terms of features, we have all the interface support, O1, O2, and E2 interface support, full-fledged modules of RLC, MAC, scheduler, and ONM. We have support for TDD and FDD, multi-UE support, and with a fairly simplistic round-robin scheduler. And there is an element, it's all, you will find some of this implementation a little elementary or basic when it comes to some of the scheduling aspects, but that's where we believe we have the ability to plug in a third-party algorithm or implementation as a scheduler with the adherence, or I would say reference compliance to the the MAC and scheduler API. So that pluggability of scheduler is a promising thing for us to play with this implementation. And we, of course, have multiple other features, including DRX, multi-bearer support, and we have tested a few flows or call flows for some of the simpler XApps with the E2 AP support. So this is where we are with respect to the ODU, and it's all integrated with the ODU low as well. We'll talk about it. And what it gives us is the ability to mix and match various different components from different open source communities. And we have tested many of these interfaces, E2, O1, FAPI interface. We've been able to test the basic logic of open front haul, or the ORAN front haul. And there are some lab-related challenges which is preventing us to claim the completeness or completion of the end-to-end testing with the real UE simulator, which probably we'll be achieving hopefully in a few weeks from now. Because of the lab, we are severely hindered, and we are trying to grab the lab opportunities as much as possible to complete this testing. So this is where we are right now in terms of the OSC and OAI integration and collaboration efforts. What we started off with is in the AT&T Bedminster lab, and again, later moved to NTUST Taiwan. There has been a lot of support from BMO, and his team, Professor Ray, has been pushing it. And we had crossed several hurdles, I would say, and with support from VIAV as well, from the RE simulator, U simulator side, we have achieved a certain level of interop. And again, sometimes we get stuck with availability of these simulators because these are shared resources many times. So we get not a continuous access, but access in chunks of time. So whatever progress we are able to make in this period, we do. And we are quite close in getting this fully interoperable front haul with the RE simulator, because we've been able to establish the basic flows already, including the timing sync. So which is giving us the confidence that the next few steps are going to be very easy steps once we get the continuous access to these simulators. And I would like to highlight the ongoing development and integration effort in collaboration with OAI. This is an important element because when we complete this, probably we are a few weeks, several weeks away maybe, we are going to show the interoperability at two levels. One is the OCU coming from the OAI community and interoperating with the ORAN OSC ODU high. And the other one is the ODU high with the ODU low implementation coming from the OAI community. So this is an important element, this is an important milestone for us because it shows interop at multiple levels and the maturity of both the implementation. So we are working towards that goal, and we will soon be wrapping up that integration. And I would not read through the complete set of the issues and challenges here, but we have made significant progress in maturing the implementation of the software here. Of course, most of the challenges are on the front of lab and integration, and that's where we are looking for broader support and not only just collaboration, the availability of infrastructure. And one thing we will ensure is to make the best use of the available resources. That's what we are currently working on. And with that being sorted out, we see a great progress further, because once we establish a working baseline among communities, it's only a matter of time to show the additional features. And that leads us to the view of what is the road ahead for this community. And one of the key things we have been emphasizing is the collaboration. And over the last 1 year, David and the OA leadership, a lot of us actually have been very closely collaborating with the communities, between the communities, and that's yielding results already. And the lab infrastructure, and I said sharing is caring. Whatever we can share, we can do, and then that expedites the implementation and integration. And of course, it builds a common expertise, and there's a lot which we have learned in the several steps of integration already. And there is a crying need of growing this community, especially with young talent, and a lot of these academic institutions and the different labs and universities can hopefully jump in and expand this community, because there's already a baseline and well-documented code which is easily accessible and can further be enhanced. And with all this said, we believe this is the right way of progressing the implementation in parallel to the standardization. We've seen this model work in the last few years, and this will be even more far more efficient when we do this in 6 years. And we believe that's the golden opportunity for the industry to provide a reference implementation as the standards develop. And with that note, I would like to conclude. Thank you.